Hi, good day to all of you. I am going to discuss today about the elliptical section on how to get the area of the section, and of course we have to define what is an ellipse. An ellipse is the locus of points in a plane, the sum of whose distances from two fixed points is a constant value. The two fixed points are called the foci of the ellipse. These are the two foci, or if it's only one, you can say focus, and that's the center of this figure. All right, so we have the equation of the ellipse below, wherein x squared over a squared plus y squared over b squared should be equal to 1. And so this line is the axis, the major axis, and the other line is, of course, the minor axis. Let's go find out the different parts of an ellipse. So first you have the focus. This is your focus. These 2 points, fixed points, right? And their coordinates are C and 0, and then negative C and 0. This is the center, and this is the axis, x-axis, which is the major axis, and this is the y-axis, and this is the minor axis. And then we also have the lactus rectum, this one. It's a line drawn perpendicular to the transverse axis of the ellipse and is passing through the foci of the line or of the ellipse. And the formula is 2b squared over a, where b is this length and a is this length. Okay, so 2b squared plus, divided by the a. Transverse axis is the line passing through the foci. The two foci and the center of the ellipse is called the transverse axis. So itong transverse axis ay nag-intersect siya sa dalawang focus or foci and the center of the ellipse. And then we have the conjugate axis. Conjugate axis is the line that is passing through the center of the ellipse, and it is perpendicular to the transverse axis. While the eccentricity is the quotient or the ratio of the C to the major segment, no? Major segment of the axis, major axis. Okay, so it means E is equals to C over A, and it has to be less than 1. Okay, so this is just a review of your lesson in ellipse when you're in your senior high school. So I suggest if you want to understand, to go back to your lesson, you can do that. But basically, in this lesson, we just wanted to know how to get the area of the elliptical section. Now, the area of an ellipse has to be equal to pi times AB. So when we talk about the area of an ellipse, it is defined as the total area or region covered by the ellipse in two dimensions and is expressed in square units like inches squared, centimeter squared, meter squared, okay, or yard squared, or square yard, square feet. And the area of an ellipse can be calculated with the help of this formula, given the lengths of the major and minor axes. Okay, so let's try an example. Find the area of an ellipse whose major and minor axes are 14 and 8 respectively. So you get this is your major axis and this is your minor axis. So A is equals to 14 divided by 2 and B is equals to 8 divided by 2. That gives you 7 and 4. So 7, looks like 7. That's why I was telling 7. So area of this elliptical section is equals to pi times AB, where A is 7, B is 4. We get 28 pi, or you can say 86.96 inches squared. You can also plug that in the calculator if you want to find out. But pi has to be 3.1416, right? So 3.1416 times 28, that gives you uh 87.9648. All right, so next we have the perimeter of an ellipse. So the perimeter of an ellipse is equals to pi 2 pi times square root of 1 half times a squared plus b squared. So wherein a is equals to 7, b is equals to 2. So when you plug into the calculator, you get 2 times the pi, okay, and then times, of course, the square root of zero point 5 times 49 plus 16, right? Okay, so you can also then press enter. That is 35.81966, or just simply get the two decimal point 35.82. Okay, so then we have the parabolic example. A tunnel with an elliptical section is found to have a depth of 16 feet. What is the area and perimeter of the section? Now, given this figure, given na yung inyong major axis or um, yes, major axis. This is your transverse axis. So this is 24 and the other one is 16. This is the B and the A and B. Okay, what is the area and perimeter of this section? Solving the area, so you get area is equal to pi times BH. So area of the sectional elliptical section is equals to pi AB. So A is equals to pi times solve for A, no? So A is equals to 24 over 2, which is 12, and B is equals to 16 over 2, and that is 8. So substitute the value. You have 12 times 8. So A is equal to, see how is 3.14, 16 times 12 times 8. That gives you 301.59. Okay, so 301.59. So this is feet. Okay, square feet. So this is your area for this section. So, okay. Now, what if we want to get the perimeter? Okay, so paano pag gusto natin kunin yung perimeter, no? Okay, let's try to find out how to get the perimeter. So perimeter is equals to 2 pi times square root of 1 half a squared plus b squared. Okay, p is equals to 2 pi times 1 half, what's a? 12 squared plus 8 squared. So 144 and 64. So pi is equals to So this is the answer. Then we have the parabolic section. Uh, Look at it as something like a wall, and then you have a decorative opening that looks like a parabola. And then of course this portion here is what you call the spandrel, the shaded one. Okay, so ito yung spandrel niya. So if you notice that the opening is parabolic in section, and we label this as the height, and this is the base. So in a parabolic section, we get the area by getting 2/3 of the area of this rectangle, or 2/3 times BH. And the area of a spandrel is of course 1/3 of the rectangular area. And the perimeter of a parabolic section, something that is challenging for you to memorize, you have the 1/2 times b squared plus 16h squared plus b squared over 8h ln, or natural logarithm of fh plus square root of b squared plus 16h squared all over b. So this is your basic formula for the parabolic section. And then let's say, well, let's do some example here. In the figure shown, find the area and region of the rectangle that is outside the parabolic section. Hanapin mo daw yung region sa rectangle na kung saan na outside siya sa parabolic section. So therefore, this shaded part is what we require here. Therefore, area of the shaded part is equals to the whole area of the rectangle minus the area of this parabolic section. So first, let's compute for the rectangle. Rectangle is 15 times 20 minus the area of the parabolic section, which is 2/3 of the 15 times the 20. So A shaded is equals to 300 minus 200. That gives you 100 square centimeters. Okay. Now, what about its perimeter? So, this is the formula for the perimeter. We just plug in the values. Okay, so P is equals to 1/2 times 20. B is 20 square plus 16. H, 15 square plus 20 squared over 8 times 15. Natural logarithm of 4 times h, which is 15, plus 20 squared plus 16 times 15 squared all over 20. So that gives us the value of 37.678 centimeters. You can actually try to see that, no? You can check that in your calculator, counter check it, and to see if we have the same answer. Okay, this will be all for parabolic and elliptical section. On my next video, I'm going to show to you the how to compute a composite shape or composite figures. So let's try to remember all the different areas of our plane figures, because that will have something to do with composite figures. So see you in my next video.